Hey, it's Coach D again, and we are on the last calculator tutorial. Yay! Category 5. Category 5 deals with quadratic and other nonlinear functions. So we'll incorporate a little bit of what we've done before, but it's going to be quite a bit of new material here. So first off, let me get my highlighter ready. The graph of y equals 3x squared minus 2 is shown below. If the coefficient of x squared is changed from 3 to another positive number to create a new function, how will the graph of the new function compare with the original one? So, how will the new graph compare to the original? Well, they didn't say what number, they just said a positive number, another positive number. So, we can pick some different positive numbers if we want. How about we change that 3 to a 1 and have x squared minus 2. And if you want to change it to a bigger number, y equals 5x squared minus 2. Okay, so go to your calculator and insert a new page with a graph. Control I, 2 for graph, and type that original. 3x squared minus 2. Okay, if it helps you to see the grid, we can change that. Menu, 2 for view, 6 for grid, and we can show the lines with 3. That's up to you. So now let's graph that second equation. Tab, and we'll type x squared minus 2. And it looks like the original equation is inside of the new one. So the new one became wider. Alright. Let's try this other one just to, make sure we're comfortable with this. I'm going to tab and insert another one. And I'm going to up arrow and type over this equation and change that x squared to a 5x squared. And this time, the parabola became more narrow. So, should it be wider or should it be more narrow? Well, what do we notice didn't change? That y-intercept didn't change. The -2 is exact same. So let's look at our answers. The x-intercepts of the new graph will be the same. Well, we know they're not the same. When you get wide or narrow, for sure your x-intercepts change. The vertex of the new graph will be different. Well, the vertex happens to be on the y-axis, and it is the y-intercept also because we don't see a linear term, so that's not going to work. The new graph will be wider or narrower than the original graph, and that's what it looks like. Let's read this last one to be sure. The new graph will open in the opposite direction. The sign of that coefficient of the quadratic changes that. So the answer is C. Okay, what is the vertex of the graph of the quadratic function? F of x equals x squared plus 6x plus 10. This is a real easy one on the calculator because we can just graph it and trace it. So let's insert a new graph. Control I, 2 for a graph, and your equation is x squared plus 6x plus 10. Now, that vertex is a special point, so we're going to trace the graph. So, menu, 5 for trace, and 1 for graph trace. And it always starts on the y-intercept, but your coordinates are going to be here. So, our vertex is going to be that tip, so I'll move to the left. And when we get there, we don't see that word popping up. Sometimes it works, sometimes it doesn't, right? So, no biggie. We'll go to menu, and we will analyze the graph. 6. We specifically want that vertex, and the word vertex isn't there, but the vertex is one of two things. It's either a maximum or a minimum. Is it the highest point or the lowest? It's clearly the bottom of the screen, so it's the lowest. It's going to be your minimum. You move your cursor somewhere to the left. If this is where I think the vertex is, I'm going to move somewhere to the left for where it says lower bound and click anywhere to the left. When I slide to the right, it's going to shade. And notice the word minimum keeps moving and moving and moving, and then when I pass the vertex, it stops. So once I realize it stops, I can click for that upper bound, and I can drag those points if I can't see them well, and I see it's at the point -3, 1. So -3, 1. And hopefully we're comfortable enough with the four quadrants to know that the signs, because that's really what's tricking people up here, is to know what's the sign supposed to be. I'm sure you got the 3, 1 part. Alright, 2 points on the graph of a quadratic function are shown in the grid below. What is the equation for the axis of symmetry of the graph of this function? The axis of symmetry. Well, the axis of symmetry splits the quadratic graph in half. It splits that parabola and it touches on the vertex. So if these 2 points are on the quadratic, it's going to be smack dab in the middle. So if I count, I have 1, 2, 3, 4, 5, 6. Then I need to be in the middle, 3. Now, why would you need the calculator? You really don't have to have the calculator again, but if they weren't values that you could use easily, say fractions and decimals, you take that x value, -6, 0, you add them and divide it in half because it's in the middle. So I'm going to insert a calculator page, say control divide, -6 plus 0 divided by 2, and that gives me a -3. And it is the x equals, that formula which is not on your formula chart is x equals negative b over 2a. Alright. What is the solution set for the quadratic x squared minus 16 equals 0? Well, the solution set, it consists of all of the possible x values. So some of us want to automatically think, oh, get the 16 on the other side. 4 times 4 is 16. That's my answer. Some of us get mixed up with the square root and squaring, and that's where we get 256. But keep it simple and just graph it, and we won't have any mistakes. So control I for a graph, and whatever you're given, as long as everything is on one side, you can plug it in. If everything's not on one side, you get it on one side so that 0 is on the other, or else just y is on the other, and then you can plug it in. So I'm going to graph x squared minus 16. And I can clearly see there are 2 different answers. So if I thought it was 4, I now realize it's a positive and a -4. So this one was wrong. This one was wrong because somebody squared instead of taking the square root. Same here. Answer choice is B. Okay, the function y equals x squared plus x minus 3 is graphed below. What are the values of x when x squared plus x minus 6 equals -4? Well, we're going to do the same thing that we did in the last problem. Like I said, we have to get everything on one side so that we either have y by itself or 0 on the other side. So this is a -4. To get it on the other side, you would have to add 4 to both sides. So I don't even want you to have to think about that. You can just show that you're adding 4. So we'll insert a new graph, Control I, 2 for graph. Type what you already have, x squared plus x minus 6. And then you can add that 4 if you didn't want to actually simplify. And now you can see the quadratic graph, its parabola touches at a -2 and a 1. That would be answer choice G. So again, it's really nice to plug in the graphs. They could have tricked you up if you didn't read and you just saw, oh, this graph touches -3 and 2, but they said what are the values of x with this new graph. So this was just to give you a visual to kind of get you to want to graph it. All right. Table of values for this quadratic function f are shown below. If 3 is one solution to f of x equals 0, what is the value of the other solution? So when f of x is 0, when y is 0, you have 3, comma, 0. Well, they're trying to trick you up here to wonder, do you know that this is when y is 0, or do you think it's when x is 0? Whenever you have a solution, root 0, x-intercept, that is when y is 0. So whenever you see a 0 on your table, I see y is 0, that's my x-intercept. When I see x is 0, that's my y-intercept. So we would do this on a grid, and our answer would be a -7. You got to put that negative. I didn't put the bubbles on here, but make sure you bubble in that negative sign. That gets a lot of people to miss points, so pay attention. And this one, actually, we didn't need it in the calculator. However, if you wanted to enter points and graph it, you would have to have at least 3 points in graphing a quadratic. And I don't need to pick the first 3. I'm going to pick whole numbers. So Control I, list in spreadsheet. I'm going to pick -7, -5, -3, and then 0, 4, 6. Arrow to the left, menu, statistics, stat calculation, and this is a quadratic regression, so 6. Arrow down and put B, Control open parentheses, and this will be graphed at f of 12. So I'm going to insert a graph now. Control I for graph is 2, and up arrow and hit enter. Now I can see, I would realize, oh, I should have got that. 3 is right there and the other one's -7. You realize I should have saw that on the table. Okay. What are the x-intercepts of the graph of the quadratic function f of x equals 5x squared plus 4x minus 1? So I want the x-intercepts. The x-intercepts we need to know are when y, when y equals 0. So what is x when y equals 0? So again, we're going to put it in the graph. Control I, 2 for a graph, type your equation, now these are not as easy to see. They're not just whole numbers, 1, 2, 3, whatever. So we're going to trace this. Menu, we'll analyze the graph instead of trace, and we can look for the 0 because the x-intercepts and zeros are the same. And the lower bound to the left, as soon as we pass it, it's going to pop up. and you can see faintly the coordinates. -1, 0. That's one of your answers. It's not a -1 and a 0, it's the -1. So any of our answer choices that don't have -1s are automatically out. Now, if your eyes aren't too good, you might think that one's a 0. So we do the same thing again. Menu, analyze the graph, 0. This time I have to go, still want to be to the left of what I think is a 0, but I can't go so far that I'm including the one I already found. So I'm going to go to the right of the one I already found, and then to the left of that. And I have 0.2. 0.2 is definitely not 0. And if you're not sure if 0.2 and 1/5 are equivalent, you go to a calculator and you click 1 divided by 5 with a decimal point, and you'll see that it is. Okay, which expression is equivalent here? Alright, this one's it's going to take a little more work. For this problem, we have an expression that is quite complex, and our answer choices look a little complex also. But they're not that difficult if we spread it out and separate all of the information. So I got 12 x to the 6th, y to the -4th, z squared. And then 3 times x squared, y to the -6th, z to the 3rd. Okay? First thing you want to do is simplify your coefficients. I'm sure we can do this in our head sometimes, but let me insert a calculator page. We want to make sure we're right. If we don't know that our division very well, 12 divided by 3 gives me a 4. That lets me know the answer choices with 9 are incorrect. Now, if we remember a little bit about our laws of exponents, when we are using the quotient rule, we're dividing, it's that top exponent minus the bottom exponent when we have a common base. So this is just subtraction. 6 minus 2 gives me a 4, so I have x to the 4th. -4 minus -6 gives me a +2 y squared. And then 2 minus 3 gives me a -1. When it has negative, I move it to the denominator and make that exponent positive. And here we have our answer choice. So just break down each piece and don't get confused with your negative exponents. Just remember that in the end, that negative value gets moved to the opposite part of the fraction and becomes positive. Okay, a table of values for the exponential function f is shown below. Which function could describe this function? So it's an exponential, and we want the one that does describe it. Okay, the value of a house increases approximately 2 3/4%. That's big. The value of a house increases $3,850 per year. The value of a house decreases by 2 3/4%, or the value of the house decreases. Let me get these keywords in here. By $3,850. So let's note we are increasing by 1 year at a time. So this first one is the easiest to see, $3,850. But it's doing that every time. So this is back to using your slope formula, y sub 2 minus y sub 1. Let's try y sub 2 minus y sub 1 on the second one. 147,806 minus 143,850, and you clearly do not get the same number. So neither of these can be our answers. Can't jump the gun on the first thing you see. Now, Is the value increasing or decreasing? Well, it's clearly increasing, so we don't even have to think about this one. We are increasing. I'm not even going to try and calculate the percentage. I don't need to. So we are finished. Record time. We are done with all 5 categories, all 6 videos. So I'm glad that you were able to utilize these videos with the help of this Inspire Navigator software and the Smartboard software. I was able to give you what I thought would be a better visual than me just writing, because my handwriting is much better than what it shows on here, but it's kind of difficult sitting on the couch writing on an airliner. So if you have any questions, feel free to email me. Here's my information, and good luck on your EOC, whatever school you're at, whatever city. I hope everyone improves their scores and passes and gets one more step closer to graduation. Thanks.